All right, looking at our Unit 5 study guide for the test for our whole unit, we're going to look at numbers 11 and 12. So suppose you buy chocolate chips and flour to make cookies. Chocolate chip costs $7 per pound and flour costs $3 per pound. You want to spend less than $21 on chocolate chips and flour combined, but you need at least 4 pounds altogether of chocolate and flour. So we're going to define our variables, write and graph this system of inequalities. So the first thing I'm going to do is I'm going to say X is chocolate chips, and I'm going to say Y is flour. Okay, the two things I know how much money I can spend, and I know how many pounds I need to get. So chocolate chips are $7 per pound, so it's 7X. And flour is $3 a pound. So 7X plus 3Y, that's going to be the money piece here. And we want to spend less than $21. So I know that I have $21. 7X plus 3Y has to be less than 21. It can't equal 21, right? It can be $20.99, but that's it. Okay, I also know that I need at least 4 pounds total. So the number of pounds of chocolate chips plus the number of pounds of flour has something to do with 4 pounds. So I need at least 4 pounds. So I can have exactly 4 pounds. That works. I can have 4.1 pounds. I can have 5 pounds. So I can have equal to 4 pounds, or I can have greater than 4 pounds. I just can't have less. So those are my two inequality statements that I'm going to work with, and I'm going to graph them. Okay, if I want to graph them, of course I want to put them in slope-intercept form. And so I'm going to rearrange, and I'm going to do this first one. It's going to be 3y is less than negative 7x plus 21, or y is less than negative 7/3 x plus 7. That's my first piece of information. My second piece of information with a different colored pen is not much of a different colored pen. Let me pause for a second. All right, let's try red pen so that we have a difference. Here you go. Okay, so if I, oops, oh no, I'm such a liar. Sorry, this really is our purple guy. Purple. Okay, so my red boundary line is going to be y is greater than or equal to negative x plus 4. I just got y all by itself. Okay, so here's what we're going to do. It looks like I need y-intercepts of 4 and 7, so I'm going to start with my purple. And at 7, I'm going to come down 7 and go over 3. Okay, this is y is less than negative 7/3 x plus 7, and so this is going to be a dashed line. All right. Y has to be less than whatever I have on that boundary line, so I'm going to be shading in this direction. All right. So my next statement is y is greater than or equal to negative x plus 4. I'm going to start at 4, and I have a negative slope again, but it's down 1 over 1, down 1 over 1, down 1 over 1. This one gets to be a solid line. So there's my solid line. Okay, so I want y to be greater than or equal to that solid line, so it's going to be greater than or equal to, it's going to be up here. Okay, I can choose a test point if I want to. It looks like a safe test point would be this one right here, 1, 4. So I am going to test 1, 4. Test the point 1, 4. It should be true for both of them if I drew my lines neatly enough. And so if I plug those back into the original, I'm going to get 7 plus 12 is less than 21. That's true. 19 is less than 21. And then my red one, I'm going to get 1 plus 4 is greater than or equal to 4. And that's true because 5 is greater than or equal to 4. So it looks like I got my shading in the right direction, and my double shaded area looks good. So one possible solution, well, I'm going to use this test point that I just came up with. If x is chocolate chips, I'm going to say 1 pound chocolate, 1 pound chocolate chips, and 4 pounds of flour should work. Okay, so on your test you'll have a blanks to fill in. You're going to have to give at least one example that you think is true. So, all right, that's number 11. Let's look at number 12. Number 12. This time you're planning to take a swimming class over the summer. So you're going to be buying swimsuits and goggles. All right, and there was a typo on probably the version that I handed out to everybody, but I have now fixed it. We're going to a local swim shop, not a local swim ship. So they're having a sale. They have swimsuits that are $14 each and goggles that are $7 each. We can spend as much as $56, and we need to buy at least 2 goggles. So I'm going to go ahead and define my variables. Because we are talking about swim class, we're buying swimsuits and goggles. Because they gave me swimsuits first, I'm just going to say X is swimsuits. And I'm going to say Y is goggles. If you ever choose the other order, you chose X as goggles and Y as swimsuits, your graph is just going to be a little rotated from what mine is, but all of the solutions will still work out. Okay, so if you chose to do goggles on your x-axis, it's just your graph is going to look a little different from mine, but your solutions will all be the same. All right, what do I know? I know that when I buy swimsuits, they are $14 each, so $14 times the number of swimsuits I get, plus $7 times the number of goggles I buy, and the amount of money I can spend is $56, as much as $56. So it can be equal to 56 because it can be as much as 56, but I don't have to spend all of my money, right? So less than or equal to 56 is what we're looking at here. Okay, the other thing that I want, and I'm going to see if I can do this in pencil instead of that other pen. The other thing that I know is I have to buy at least 2 goggles. So goggles is Y, so the number of goggles I buy has something to do with 2. Goggles has to be, it could be exactly 2, or it can be more than 2. It can be 3 or 4. So those are my 2 inequality statements that I'm going to place on my graph. All right, my first one here, 14x plus 7y is less than or equal to 56. I'm going to go ahead and make that into slope-intercept form. So that's going to be 7y is less than or equal to negative 14x plus 56. Y is less than or equal to negative 2x plus 8. And I divided by a positive number, so I don't have to change the direction of my sign, which is just lovely. All right, so this line is going to be starting at 8. I'm going to have a slope of negative 2, so I come down to over 1, and it looks like that. It can be equal to this $56, so I'll have a solid line. Okay, it has to be less than or equal to all of that boundary, and so I'm going to shade all of the stuff that is less than the boundary line. All right, next, I know y is greater than or equal to 2, so here's 2, and oh, that's hoy, so it's just going to be a horizontal line at hoy, right? It is a solid line, and y has to be greater than or equal to that boundary, and so my double shaded area is this wedge right here. Okay, so anything in that wedge ought to work fine for me. So one possible solution, we defined x, this is x always, right? We defined this as swimsuits. And we defined y as goggles. Let's see if I do that sideways. So an example of something that would work, I could buy 2 swimsuits and, 2 swimsuits and 3 goggles. 2 suits and 3 goggles. You may have chosen a different point that works for both, so maybe you buy 1 suit and 5 goggles. 1 suit and 5 goggles. 1 suit. And you can always plug those solutions back in. This time I didn't just pick a random test point, I just picked a couple test points. If you plug those pieces of information back into your original inequality statements, they will be true. So great. Thanks for working hard to be sure you're ready for the test.